So hello viewers and welcome back to another video on networking. So we are actually continuing our series on this topic, that why we don't run out of IPv4, and for that we have seen the concept of NAT and PAT. We have seen all these parts where we have seen an introduction, netting and patting, and we have also seen the simulation in the CPT for the NAT. So in last video we have seen the static NAT configuration, and now in this video we are going to see the dynamic NAT configuration. So without wasting much time, let's jump onto the Cisco Packet Tracer and let's see how that works. So we had this topology, and I think you are familiar with the topology. So this is the router and there are two networks. So this network is like public network and this network is private network. Suppose this is your home network and this is internet, where we have this website hosted over the internet and that carries the IP address 10.10.100.20/24, and this is your router, where inside your network or inside your private network the IP address is 192.168.10.0/24, and you have two end devices, 10.2 and 10.3. Now in the last video we have configured the static NAT. So let's just have an overview of the last configuration that we had in the last video. So if we go inside user executable mode and we hit show run, which means show running config, so you can see this was the configuration. So in fast Ethernet 0/0, this, which is this interface, so inside that we have configured IPNet inside, which indicates that this interface of a router is connected to private network. And on the fast Ethernet 0/1, which is this interface, over there we have entered IPNet outside, which means this indicates that this interface of a router is connected to public network. Now whenever the packet comes to private network and the next hop address of the packet is the interface which is connected to public network, at that time router will use the netting configuration that we have had and apply all the configurations that we have did. So for that, in last video we have did the static configuration. So static NAT, which means just the one public address will be allocated to one private address. So here the private address was 192.168.10.2, which means the IP address of this machine. It will be getting translated to 10.10.100.2. So that is the static mapping, where only one address of a private network will be translated to one single public IP address. Now in today's video we are going to see the dynamic NAT, and for that first of all we'll remove the existing configuration. So to do that we'll go inside the global configuration mode, and with entire this command we can just use, okay, we select this, copy this and then paste here. Okay, that is it. And I think if we go back to user executable mode and just hit show run, which means show running config shorthand, so I think the static configuration, static NAT that we had configured, that got removed. Now we have plain configuration. We don't have any static or any NAT or PAT configuration. We can test that by just issuing a ping from this to this. Okay, I think it will fail, but the second packet will, it was a success. And we'll just observe the packet if okay, first of all we'll delete this packet. Okay, now we will ping, and if we can just observe this packet and we can see inbound the source IP is obviously the IP address of this machine, which is 192.168.10.2, and the destination IP is 10.10.100.20, and in the outbound it says the same. That means there is no such static NAT configured. Now when it comes to dynamic NAT, what is the dynamic NAT? In that we have the pool of what you can say private addresses and pool of public addresses. Now our router will dynamically allocate whatever IP addresses that are free, the public IP addresses, that will be allocated to as and when required by the private IP addresses. So we have two different pools, one which is public addresses and one which is private addresses. So those pool will be dynamically mapped. I mean, these private addresses will be dynamically mapped to one of the available public IP addresses, which is not in use. So how to do that? So for that, we just need to follow this configuration command, and which are like this. So for that, first of all, we need to enter global configuration mode. Once we are in the global configuration mode, what we can do is we need to first create the private address pool, which means what is the pool of public address pool. What is the pool which will be used to allocate the public IP addresses. So for that, we can use the last command, IP NAT. Now after that, we can hit question mark, and as you can see, we have the option pool. So we can use pool. Now word, which means what should be the name of this pool. So we can just say NAT Hanil. You can just enter any name. After that, we can hit question mark. You can see what should be the start IP address for this pool. So let's enter 10.10.100 dot. So 1 is allocated over here. We can start our IP address with 2, and now we hit question mark. And what should be the end IP address? So let's just enter 10.10.100.20. Now question mark again. What should be the net mask? So let's enter 255.255.255.0. And yeah, so that's it actually. Okay, I think we should give the what you can say 0.255.255.255. And now okay, so after the end IP address, I think we need to hit prefix. Okay, net mask, and then we need to write net mask and then network mask 255.255.255.0. Yeah, that's it. So we have configured the pool of public addresses. Now what we need to do is we need to define an access list. An access list will help us to filter out the private IP addresses that we want to translate. So for that, we can use access list, then we can enter question mark. So now standard and extended, so we can just use standard. So access list 1. Now what IP addresses, so what rule we want to incorporate? We just need to use the permit, because we want to permit the private IP address translation, right? So permit, permit, and then address to mask any or host. So let's say address to mask is 192.168.10.0 and wildcard bytes, which means the network mask, but in the reverse order. So 0.255.255.255. Okay, so that's it. So this is the command. So we have created two things. The first is the pool of public addresses, and the access list, which maps us with the addresses, which helps us to permit the private IP addresses that we want to translate. Now somehow we need to connect these two, which means we need to say router that, hey, whatever IP addresses that are permitted by this access list, please map those with this public address pool whenever we want to send our traffic from inside to outside. So for that, we can use just one command, which is IP NAT, then inside, then source, then list, then the list of source. So list of list actually, which means access list. So the rule number 1. So we have used access list 1. So let us use access list. Access list. Damn. Okay. IP NAT inside source list 1. After that we need to use pool. So with this pool, with this access list, what should be the pool that you want to connect? So pool, then the word of the pool was NAT-HENIL. So NAT-HENIL, and I think, yeah, that's it. So now what will happen is, whenever our router will receive a packet into any of the port that says it is connected to inside network, and if it is if the next hop for that packet is the interface which is connected to outside of the network, the rule that we have just included, that will be used. So now let's just observe that how it happens. So we can just enter a packet and it says it is successful. We can enter the simulation mode. Now we will start a packet from here to here also. So as you can see, this packet from PC0 reached to router 0, and let's now observe the inbound and outbound. So you can see inbound is 192.168.10.2 as expected, and destination is 10.10.100.20, that is also as expected. But now you can see the outbound, the source IP got translated to 10.10.100.2 and the destination is 100.20. Now if you observe the OSI model, you can see this in the action. Yeah, over here. So you can see the packet is going from inside to an outside network. And how it got detected? So router will observe the source and destination IP. It will find that the destination, so that is also over here. So you can see it receives the MAC address and the device looks up the destination. So here it will observe the routing table and finds that the destination address that this packet wants to reach is connected to this fast Ethernet 0/1. And now after that it will say that, oh, it is going from inside to outside. Then we need to look at the NAT table, and source list is matched. So basically source IP was 192.168.10.2, which matches the access list that we have just created. So the device translates the packet from the local to global addresses with the matched entry. That's how it got translated. We can just use this magnifying glass and observe the NAT table. So you can see 10.10 inside local. So 192.168.10.2 is mapped to 10.100.2 inside global, right? And now we can say this. Okay, so this was ARP packet. Yeah, this was ARP packet. We can close this. Yeah, so this is now will be reply. So you can see again the inbound is 10.10.100.20 and destination is 10.10.100.2, but the outbound, the destination IP changed to 192.168.10.2. Now how it happens is, so you can see the packet is coming from outside network. So it detects that packet is coming received on this port which is connected to outside of the net, and that has the what you can say NAT configured. The device has NAT configured. So now the device translates packet from the global to local with the matched entry, and now it sends the packet, and we can observe the NAT table. The entry will still exist. Okay, magnifying glass, NAT. So you can see this entry still exists. Now let's see what happens with the packet which is sent from 10.3. So you can see the router received the message with the source IP of 192.168.10.3 and the destination is this server's IP address. But you can see this address was also translated to 100.3, and that's how the packet will be sent. Now this server will not have the what you can say MAC address for the IP address of 100.3. That's why it will prepare an ARP packet. So as you can see, this is target MAC is not found. That's why it will prepare an ARP packet, and you can also observe the ARP packet. The target IP is 100.3, and now the ARP packet will replied with the fast Ethernet 0/1's address, and now the server will prepare the packet. It will be sent to this router, and as you can see, source is 100.20 and destination is 100.3, but it is translated back to destination IP 10.3, 192.168.10.3. And over here now we can just observe the NAT table. as you can see, 10.3 192.168.10.3 that is mapped with 10.10.100.3, and these are the inside outside local and outside global. So yeah, that's how the packet will be mapped, and you can see clearly the difference. So in last video we had just the static mapping where only this IP was translated to public IP address, but now since we have dynamic address, we can see that both of these private IP addresses are translated to public IP address. But now there is one problem. If you want to have public IP address, you need to pay, as you will be using the IP addresses, because if you want to use public IP address, you need to pay a fee for that, and that's why it is not feasible to use the dynamic netting, because we might want to, so here you just have 2 devices, but imagine there is an enterprise and there are hundreds of devices, so you can't purchase 100 public addresses for all of those private addresses. And also you cannot block, let's say you just have 2 public IP addresses, so at a single time you can just have, what you can say, 3 simultaneous connections with the internet, because you only have 3 public IP addresses. That is also not feasible. So what instead you can do is you can configure PAT, which we will see in the next video. So yeah, that's it for this video. I hope you have got the idea about dynamic netting and static netting, and we'll see in the next video. We'll meet in the next video and we'll see the PAT, how to configure PAT in the Cisco Packet Tracer. Until then, keep learning and keep exploring. Bye bye.